All right, so hi everyone. So I welcome you on today's session. So earlier in the last session, we discussed about big data. What are the so just a quick revision I want to give. What is big data? What are the 5 V's of big data? What is scaling, and what is horizontal and vertical scaling, and which one is good for big data perspective? Yes, so today we are going to study one more important concept. Basically, I will not be covering in too much depth because it has not is now much relevant. But it's important to understand because ultimately Spark is basically going to solve, or I would say that it's a replacement of this concept or this terminology or this paradigm. It is called MapReduce. Okay, so what is this MapReduce? So when our actually the data is getting originated, now to handle that, to process that big data, they come with a computation terminology, a computation process. That process is basically a MapReduce. It is made up of two things, basically map and reduce. Okay, so what is MapReduce basically? So it's a Java based, very important. MapReduce is a Java based distributed execution framework within Apache Hadoop ecosystem. Okay, so basically if you want to process big data, if you want to process it, then for this they have designed a completely different framework, and that framework is basically a MapReduce, and it is Java based. Most important thing means whatever you want to process the data, you have to write a code in Java. Okay, in MapReduce. Okay, now it's take away the complexity of distributed programming by exposing two processing step that developer implements. So there are two basically process, I would say three typically, but majorly overall it's map phase and reduce phase. Okay, now both these map and reduce phase work on key value pair. I will tell you, means we will see what do you mean by this key value pair, how they are processing it. Okay, so it's basically a processing framework. So what Spark is doing, Spark is just a replacement of, you can say, a MapReduce. Okay, so how does MapReduce work? So MapReduce basically consists of three stages. First one I told you, that is the map phase. Another stage where shuffle, combining and partitioning happening, and third phase is the reduce phase. Okay, reduce phase is happening. So how it's work, let's focus first on map phase. Okay, uh, just why we are studying this, to get the basic idea about MapReduce. Okay, I am not digging too deep into it because it will set the tone for your Spark. Okay, so just have a basic idea. Right now in present moment industries, very less work is going on the MapReduce. It has become obsolete, I would say. Okay, but Spark originated from this only, means the origination start from this. So here what happened in the map phase, suppose you have an input data. Okay, you have certain data, now that input data is first split into smaller block. Okay, suppose you have a data, now it's going to split in a small block. Okay, Hadoop framework decide how many mappers to use. So internally, inside MapReduce concept, internally there runs a mapper. In map phase there runs a mapper. Then how many mapper is going to run, that is defined by Hadoop framework based upon the size of data. Depending upon the size of data, mappers will be used. Okay, and the memory block available on each mapper side. Okay, now each block is then assigned to a mapper for processing. So each block, suppose this block corresponding to mapper 1, this block corresponding to mapper 1, or this block corresponding to mapper 2. So typically here two mappers are there. Okay, in map phase. Now each worker node applies the map function to the local data and write the output to temporary storage. Okay, so each worker node, it will process your data, each mapper will process your data, you can say, and it will write the output to a temporary storage. Okay, now write the output after processing it. Okay, write the output. Then comes the another stage, that is shuffle, combining and partitioning. Okay, so what this is happening, suppose your data is distributed across multiple mappers, right? Then shuffling is happening. So data which is of same kind will come to one node, data which is of another kind will come to another node, right? So worker node redistribute the data based on the output keys produced by the map function. So map function, you are processing a data and data is coming in the form of key value pair. Okay, now the data which corresponding to a similar key will be go to the same node. Okay, out produced by the map function such that all data belonging to one key, here it is written, is located on same worker node. Means data which belongs to same key will go to the same worker node. We will see the diagram so it will be more clearer to you. It's a very simple term. As an optional process, the combiner is basically a reducer. Combiner is what? Reducer. Can run individually on each mapper server to reduce the data on each mapper, even further making reducing the data footprint and shuffling and sorting easier. So what is the basically work of combiner? Combiner is basically a reducer. Suppose you have a huge volume of data, and so the combiner will run internally. Okay, and it will see whether it can reduce your data size or not. Okay, or this shuffling, sorting, this happen internally, so it will be more easier internally to process the data, right? So that's the main work of combiner. Then another last phase comes the reduce phase. The reduce phase is basically, you can say it's an aggregation phase. Aggregation phase. Okay, a reducer cannot start while a mapper in progress. That's a very important line. A reducer cannot start while a mapper is still in progress. So first mapper needs to complete their job, what the map function output is come, then the reduce phase start. Worker node process each group of key value pair output data in parallel to produce key value pair at output. All the map output values have the same key. Okay, that we have told, means whatever output we are getting with the help of map function, so particular mapper corresponding to a particular key. Okay, and that key given to the single reducer, which then aggregate the value of that key. Unlike the map function, which is mandatory to filter and sort the initial data, the reduce function is optional. Means reduce function is not mandatory process internally, but if it is applicable, it can improve the processing speed, because its ultimate objective is to do aggregation. Okay, so there are certain limitations of MapReduce. First limitations is that there is lot of IO operations are involved. Lot of IO operations means, suppose for every read and write there is IO operations are involved. Okay, suppose there are 100 read and write operations are there. Suppose you are reading data, then you are writing it, so 100 IO operations will be there. And suppose your data is very huge, then lot of read and write operations will be there. So there are a lot of IO operations is there, which ultimately decrease or you make your system slower. Okay, another limitations is what having MapReduce, it cannot cache, or you can say it cannot store the data for temporary purpose for intermediary. Okay, which further diminish the performance. Okay, so in Spark, as you say, so Spark having a capability to cache the data. We will study in Spark when we are going to study about RDD. Okay, that in RDD comes with certain function, that is what cache and persist. These are some of the optimization technique we will discuss in detail when we study, so that you can store your data intermediary. Suppose certain data you need faster, you don't need to reprocess it every time, or data which you are using frequently. Okay, basically what is the objective of using cache and storing intermediate? Suppose while you are processing anything and certain results or certain operations you are using frequently, you don't want your system to reprocess it every time, right? So you cache that data. Okay, so that MapReduce don't have that facility to cache the intermediate data in memory. Okay, another thing is that it is not suitable for batch processing. Okay, or for huge batch processing means your data is coming in a lot. Suppose one lot came, another lot is came. So there are typically two types of processing. Batch processing is there, and real time processing. Real time processing is that your data is flowing in a real time perspective. You can say streaming data. Streaming data means your data is coming using Kafka is involved in the process. Okay, Kafka is an open source tool to handle the streaming data. Okay, so we are not studying Kafka here, but just for your knowledge I tell you. And there is batch data. So initially the history in big data, they started from batch data, means data is coming in lot. Suppose 1 GB 1 TB data is coming, and another data is your real time data. So your MapReduce is only suitable for batch processing only of a huge amount of data. If you are handling with the real time data, you want to handle it, then you can't do it with the help of MapReduce. And also another limitation is that for a single operation, for a simple operations, you have to write a very complex code in Java. So that's also become very troublesome for developers, right? So these are certain limitations. Now to overcome these limitations, there comes the basically Spark. Okay, so this is basically a diagram. So here you can understand very clearly, means what is the whole steps and processes we were discussing it. So suppose you have an input data. Okay, suppose this is your data. Welcome to Hadoop class. Hadoop is good, Hadoop is bad. Okay, now my objective is that I want to calculate the frequency of each word. Okay, as you can see in the final output, I want to calculate. So welcome comes for one time. Okay, and 2 comes one time. I think is come 2 times. Okay, Hadoop come 3 times. So I want to calculate the frequency of a character of a letter in a sentence. So with the help of MapReduce. So first, this is your input. Okay, now input first is going to split. So we have splitted our input. Then this will send to the mapper. Okay, mapper is going to work for these input, and as we discussed that it works on key value pair. Okay, so the output will come in the form of key value pair. So this is your key and this is its value. Okay, this is your key, this is its value. So welcome key value 1, Hadoop is the key value 1. Okay, here you can see class key value pair, Hadoop key value pair is key value pair. So your output you are getting in the form of key value pair. Here you can see good key value pair. Okay, Hadoop key value pair is key value pair, bad key value pair, right? I hope that's clear to you. What do you mean by key value pair? Now basically what internally shuffling will going to happen. What is the objective of shuffling? Means data which is of same key value pair will be come at one worker node. So as you can see, you have a data welcome 1. So welcome 1 comes at one worker node, then 2 1, then is 1. Okay, basically all type of sorting, all type of filtering, all type of partitioning, all type of shuffling happen in this phase. Okay, so don't you think if this is happening, then our work will be more faster? Okay, internally the system don't needs to work more. Okay, so this is shuffling happens. Now last stage is of reducer stage. I told you it's an aggregation state where we're going to aggregate the data. Now our objective is what? Our objective, we have to count the frequency of each word in a sentence. Okay, so we got that Hadoop came 1 1 1. We get the data from different worker node and put it in a single worker node with based on the key, common key, right? So here we are doing aggregation. As you can see, we have aggregated, and Hadoop 3 times came, good 1 times came, class 1 times came, bad 1 times came, 2 1 times is 2 time, welcome 1 time, and this in this way we get the final output. Okay, I hope that's clear to you. If still you have any doubt, just rewatch the video. Okay, just go at a slower speed. It will be very clear. It's not that tough. Just for understanding, Right now we don't need to learn about Java, we don't need to code in Java. It's not the requirement, it's not the in demand skills. Okay, so just for your understanding, because Spark is solving all the complexity and glitches of MapReduce only. Okay, so I hope that's clear. So here I have there is one more diagram we can see here. So we have an input phase. Okay, then the mapper will run, it give an output in the form of key value pair. Okay, this you can see key value pair is there, key value pair. Then combiner works, it's an optional. So combiner is uh, based on common key, based on same key, it will arrange, sort, shuffle the data, right? Combiner is grouping the data basically, then shuffle and sorting happening. So this is shuffle and sorting happening, then reduce phase, basically aggregation, and output phase. So I hope this is pretty much clear, means what are the phases that are involved in MapReduce. So you have your input phase, you have your map phase, then your combiner works, then your shuffle sorting happen, then reduce phase, then your final output. Okay, so if you want to understand the difference between Spark and Hadoop, I mean this is also very interesting. So let's see. So processing speed, you can say that in terms of speed, if I compare between MapReduce and Spark, then Spark is pretty much faster than, because lot of IO not involved in Spark as compared to MapReduce. Okay, and data processing paradigm. So you can say that MapReduce is designed primarily for batch processing. It doesn't deal with but we can do real time, but it's primarily designed for batch processing. Okay, Apache Spark is more suitable for real time data processing. Okay, and ease of use, if you talk about Apache Spark, is more user friendly. We will see when we are studying with Databricks, and when we use Spark, then we'll come to know, okay, why it is more user friendly. And another thing is that you don't need to write a very complex code, means just for this we will see this example also, means I will show you the snapshot, means the last example which we discussed this. If we write a code in MapReduce, then how the code looks like, and if we write a code in Spark, then how the code looks like. So it will be much better for you to compare that which one is easier. And fault tolerance, so Apache Spark consists of RDD. Now what is RDD, we are going to discuss in detail. Okay, so if you anyone is reading first time, anyone is watching this video and came across this term, then no need to bother, we will study in detail what do you mean by RDD. But those who have studied, so just for understanding I am telling, it's the most fundamental data structure in Spark, that's it. Okay, offer better fault tolerance. Why it is called fault tolerance? Because you can retrieve your lost data with the help of RDD. We will discuss this in detail. Okay, integration, so Apache Spark gives you more flexibility in term from integration perspective. If you want to integrate your data with so many databases or data visualization tool, or you want to integrate your data with you can say real time data processing. Okay, so Spark gives you more flexibility as compared to MapReduce, because basically MapReduce is designed to work with Hadoop distributed file system. Okay, so yeah, I mean this is pretty much clear. So today we studied about what is MapReduce, what is the architecture of MapReduce, what are the processes involved in MapReduce, what are the limitations of MapReduce, means which Spark is solving. So I hope you like the session. Do subscribe to my channel, and yeah, thanks for watching. Thank you.